Interfaces, by definition, are very exciting for scientists. In particular, biointerfaces, which means the interaction or the interface between biology and materials. And this, by definition, is a very interdisciplinary field, ranging from biologists, natural scientists, to medical people and engineers, all investigating and doing research on the question what happens at these interfaces and how this could be used in the future, for example, for new therapeutic treatments.
There are many things that one can say about biointerfaces, and one which is very obvious is to think about how we can improve healthcare. I want to add to this that bio is not only healthcare. There is many interesting things that we need or we want to solve where biointerfaces are critical. I want to bring just one example, maybe, in addition to clinical importance. For example, marine fouling is another biointerface where we, as material scientists, have no solution yet. And this impacts many industries. It impacts our economic growth. It impacts our energy efficiency. So the ideas that I hope would be critical to think about technologies of the future have to do with unusual new approaches that we haven't tried yet. I find approaches related to dynamic materials, responsive materials, to be very critical. I find yet another area that is not explored sufficiently is to create materials that are multifunctional. We don't have a lot of examples in artificial materials of that kind. And by multifunctional, I mean that these materials change their function if they have to perform both mechanical and optical function, optical and magnetic function, depending on what they're supposed to do in different conditions. So I believe that if we, as material scientists, or at least I would like to bring up the side of the interface, which is material science, chemistry, and engineering, if we would think about new approaches, disruptive approaches, not necessarily very small steps in the same directions that are traditionally used in science, we can get somewhere. And this is where bio-inspiration is critical. Combining lessons from nature, unusual lessons that makes us maybe uncomfortable a little, but trying to bring them to chemistry, physics, and material science may give us interesting ideas.